Good afternoon or good morning, depending on where you are. Before we delve into the heart of our discussion, I would like to acknowledge the traditional custodians of the land. The profound wisdom and rich traditions of First Nation cultures remind us of the significance of learning from the land, each other, and our shared experiences. We gather here today in the spirit of learning and growth, acknowledging that knowledge is a journey we embark on together. Thanks for joining us today. Before we get started, a few housekeeping notes. All microphones and chat have been muted for the webinar. We will have a question and answer session with the presenters at the end. Please email your questions to rpaswebinar@casa.gov.au. You'll see it on the screen and it's on most of the slides through the presentation. And if you could keep the questions as concise as possible to help the panel provide clear answers. Presenting the webinar today, we have three inspectors from CASA's Regulatory Oversight Division. RPAS team leader Heath McDonald, who will explain how the intrinsic ground risk class calculations work under the Temporary Management Instruction, or TMI. Senior Inspector Warwick Hickson, who will demonstrate how to apply the TMI with real-world scenarios. And Senior Inspector Darren McGrath, who will moderate today's session and the question and answer component. I'm Rowan Kimber, Senior Standards Officer in CASA's RPAS Policy and Regulation section under the stewardship of Jacqueline Smith. I have the pleasure today of introducing the webinar and discussing CASA's SORA journey and the background to the TMI. Before I dive in though, I'd like to acknowledge all of my colleagues at CASA who work tirelessly to balance enabling aviation and keeping Australian skies safe. It's not an easy task. The TMI we're going to discuss today is very much a team effort and I thank all involved. I'd like to extend that thanks to all the members of Australian industry who contribute to JARIS and more broadly contribute to our collective understanding of the SORA methodology and the risks involved in RPAS operations. All right, let's dive into SORA and our journey. SORA, or the Specific Operations Risk Assessment, is a methodology developed by JARIS, the Joint Authorities for Rulemaking on Unmanned Systems. We're working on changing to uncrewed, we'll get there. It's an international group focused on unified safety and operational requirements for UAS integration. CASA has been an active JARIS member since 2015, contributing heavily to SORA's development. In 2018, CASA adopted an early version of SORA for assessing complex BVLOS operations, later making the updated SORA 2.0 model the preferred methodology for such assessments. For those unfamiliar with SORA, here's a 30-second breakdown. I think I can do it in 30 seconds. We'll give it a crack at least. SORA calculates risk based on the probability of fatalities from an impact, considering population density and the operational area. It used a target of no more than one fatality per million operations for people on the ground to set reliability thresholds, or SAIL levels, from 1 to 6. Higher SAIL levels demand stricter operational and airworthiness requirements, called Operational Safety Objectives, or OSOs. For example, SAIL 2 operations allow one loss of control of the operation event every 100 hours, while higher SAIL levels demand exponentially greater reliability. SORA's air risk component evaluates encounter probability and mitigations to meet the safety targets, feeding into the SAIL level. In Australia, SAIL 2 is typically quite manageable, and CASA is currently working towards proving operations at the SAIL 3 and SAIL 4 level. Obviously, there's a little bit more to it, and I went a little bit over 30 seconds, but that's SORA in a nutshell. Unlike other nations, SORA is not enshrined in Australia's RPAS rules. That gives CASA the flexibility to approve operations under alternate methodologies when SORA isn't fit for purpose. That said, the SORA 2.0 model remains CASA's preferred methodology for BVLOS and other complex operations. It's worth noting that from the outset, there have been some complications with the application of the SORA model to Australia. CASA was aware of these challenges before commencing use of the model. It's really difficult to create a risk model that considers the nuances of each local environment. We've got a large country with vast areas of low population density and a generally outdoorsy population. Additionally, many crewed aircraft in Australia are not equipped with electronic conspicuity devices, and we have limited dynamic population data. All these factors and more impact the model's workability and influence CASA's consideration of a safety case. And we're not alone with facing these issues. The JARIS community has been working to improve the model. Earlier this year, as I'm sure many of you are aware, SORA 2.5 was released, moving from a largely qualitative model to one with a more quantitative back end. CASA was heavily involved in the development of the updated model, and we vigorously advocated for the Australia perspective. The result is a new SORA model, version 2.5, which we expect will better identify risks and the required mitigators for Australian operations. However, there's still significant work to do globally to take the model from a JARIS publication to local adoption. Like any large body of work, particularly one with global application and input, there are elements in the new model that work well in theory, but not in practice. CASA continues to work with the wider JARIS community to iron out the wrinkles and identify the necessary local changes as quickly as possible. There are, however, several changes in the new SORA model that we believe can't wait for a full rollout. We were quite vocal within the JARIS community to get certain changes, and we're keen to implement them as soon as possible. And that brings us to the topic of today's discussion, CASA TMI 03 of 2024. The standout issue in SORA 2.5 was a lack of granularity in the ground risk model. Those who use SORA regularly will shudder when I say the words sparsely populated. Under SORA 2.5, the model only had 3 population bands, the lowest of which was sparsely. There are significant differences in the quantitative interpretation of sparsely populated between Europe and Australia and other nations, and that caused us some pain. The move to a quantitative methodology introduced 7 population bands based on orders of magnitude. After much negotiations at JARIS, Australia managed to get 50 people per square kilometre and, with significant raised eyebrows, 5 people per square kilometre added to the model. Adding 0.5 people per square kilometre was a step too far, with the international community not believing that we really do have a use case for such low densities, and some. However, Australia has added this 8th band in the TMI to better reflect our unique conditions. Introducing the granularity of SORA 2.5, including Australia's special of 0.5 people per square kilometre, has the potential to significantly improve the processing of SORA applications. This increased granularity allows for a more accurate assessment of the ground risk, tailored to the specific conditions of different operational areas. It helps in better identifying and mitigating risks, leading to a more precise and effective safety measures. By incorporating these detailed population bands, we can ensure that the risk assessments are more reflective of the actual environment, which in turn enhances the safety and feasibility of RPA operations. This approach also facilitates a more streamlined approval process, as the risk levels and required mitigators are clearer and more specific. To achieve this incorporation, elements of SORA 2.5 ground risk mitigations were also included, as was the new optimal grid resolution table. To explain how all of this works in practice, I'll hand over to my colleagues from CASA's Regulatory Oversight Team Division. Starting with RPAS team leader, and I should say CASA's Aviation Authority focal point at JARIS, Heath McDonald. Thanks, Heath.
Thanks, Rowan. And thanks to everyone who has joined us today. What I'll take you through now is some of the key differences in the TMI compared to the SORA 2.0 documentation. In particular, how the iGRC should now be determined, given the increased granularity within the iGRC table. In simple terms, the iGRC table divides critical areas into columns. The critical area refers to the likely size of the area that could be impacted if the RPA were to crash. Under SORA 2.0, kinetic energy was used as a parameter to determine the critical area. However, JARIS has since determined that kinetic energy is not the most accurate method for defining this area. As a result, the focus has shifted to the dimensions of the RPA, so how large it is, and the maximum speed, how fast it can fly. Table B in the TMI provides guidance on how to determine these 2 factors, with further details included in the JARIS SORA 2.5 main body document, which you can access via the JARIS website. So to put this into context, example 1 identifies a fixed wing aeroplane, RPA, with a wingspan of 3.5 meters and a maximum commandable airspeed of 30 meters per second. And while the speed would place it in the second column, the dimension places it within the third column, meaning that this system would be considered in the third column overall. Example 2, on the other hand, is a high altitude platform with a wingspan greater than 20 metres, which places it in the highest or far right column. I'm using this example to segue into the NXF publication, which can be found on the JARAS website as well. As part of our incremental steps towards updating SORA, CASA is yet to formally accept the critical area calculation methods outlined in NXF. Example 2 may represent a scenario where the generalised critical area columns do not accurately reflect what the defined critical area should be. However, it is challenging to define when and where NXF can be used currently, as we haven't formally accepted it. However, the publication is available, and we will definitely appreciate any early engagement if you believe there has been a significant miscalculation of the critical area for your system. Now let's move on to the ground risk class calculation. As you can see in the diagram, the squares represent areas of population, with a larger square indicating a region of higher population density. Prior to the release of the TMI, CASA accepted a method where an application would present the operational area, contingency volume, and ground risk buffer, encompassing all areas as shown here. And through the use of M1 mitigations, we would allow for areas to be excluded within the operational area to reduce the iGRC, which would often result in a reduction of the sail level. Essentially, this approach introduced some level of granularity within the model. However, it was quite challenging to assess, and the lack of clarity around the term sparsely populated led to some inconsistencies. In short, with SORA 2.0, we had limited flexibility when it came to the typical Australian operational environment. With the new TMI, this introduces multiple population bands and descriptors, providing a more detailed approach to calculating the iGRC. Now, I'll admit I'm not the greatest artist, as you can probably tell from my very basic diagram here, but hopefully this helps to clarify how we expect the iGRC should be calculated under the new TMI, and taking into account the various population bands and the qualitative descriptors. When developing your application, it's important to identify the entire area where you plan to operate, including any areas you will not be operating in, and calculate the iGRC based on this full area. And this should be calculated at the very start. M1 mitigation should only be used for specific purposes such as sheltering or temporal arguments. For example, if there's a school or industrial estate within the area and you do not exclude these, you can present a claim to limit operations based on the time of day or schedule to reduce the risk. This approach helps ensure you can still achieve the desired iGRC score. For sheltering, which is probably one of the main mitigations that will be used, you need to ensure that people are within suitable structures during the period of operation. For example, a sheltering claim where operations are conducted during the lunch times may not be accepted, as these are times where people are more likely to be outdoors and not fully protected. Digging down a bit deeper into the quantitative and qualitative. So the quantitative population density assessment relies on using a valid data source, and ABS census data is generally accepted for this purpose, as it provides a solid foundation for understanding static population distributions. However, to ensure the accuracy of the assessment, this data must be matched with the qualitative descriptors to capture a true representation of the operational environment, which can be observed through satellite imagery or on-site validations. A clear and detailed area description is crucial to avoid underestimating risks and to accurately determine the iGRC value. This is particularly important when the available grid size resolution exceeds the optimal level, as this can obscure finer details that are essential for the assessment. While quantitative data serves as a baseline, the qualitative assessment should carry more weight. This ensures a comprehensive evaluation, especially in complex or high-risk environments, where numbers alone may not fully reflect the operational environment. In some cases, the qualitative assessment may lead to an increase or a decrease in the iGRC value compared to the quantitative assessment. And it's really dependent on the specific characteristics of the area. By integrating both the quantitative and qualitative assessments with an emphasis on the qualitative component, this will achieve a balanced and more accurate evaluation. And this approach is vital for determining actual risks and ensuring we maintain the target level of safety which underpins SORA. I'll now hand over to Senior Inspector Warwick Hickson, who will guide us through some examples of applying the method in the TMI. Warwick?
Thanks very much, Heath. Before I just carry on with my element, I just wanted to bring a quick bit of attention there to the bottom of the slides where we have our email address for any questions that the audience may have. Please make sure you send them through whilst we're going through the presentation. Thanks very much. So, putting the TMI into practice. So we begin by providing some ground rules for these two scenarios that we're going to go through. Both scenarios will focus on changes to ground risk as defined in the new TMI. The operations are conducted with the same RPA, weighing 10 kilos with a dimension of less than 1 metre, travelling up to a maximum speed of 21 metres per second. The airspace will be considered operations below 500 feet and reflective of Arc B. Now, looking at the RPA chosen, the RPA characteristics suggest an RPA that fits within column 1. So just a quick advantage with this is industry that utilised these RPA previously for this scenario would previously been placed in the second column, and this is due to the use of kinetic energy and the fact that these RPA would have been greater than 700 joules. Now, due to the shift to maximum speed, the RPA gains a column advantage. So the purpose of scenario 1 is to achieve an outcome of SAIL 2. So just reiterating an earlier point as well, if you believe your RPA is not representative of the column associated with the characteristics, CASA may consider an argument for a specific critical area calculation. However, these will need to be reviewed prior to the application to determine whether CASA will accept the claim. And as Heath suggested, the early engagement is essential. So looking to the right-hand side of the screen, we have selected this area of the operation depicted in blue. Now, from the ABS data gathered, we can identify that the quantitative assessment of people it identified 36 people per square kilometre, which aligns to a quantitative population value of less than 50 people per square kilometre. However, to reiterate an earlier point, CASA will generally use the qualitative assessment to determine the appropriate operational scenario. When looking to the north of the area, you can identify a school. Now, with the school, it does not align with the ABS data and identifies a gap in our assessment. So just a point to note, the ABS data is correct to a specific point in time. Whilst it can provide a broad representation of the population, it fails to provide accuracy where transient populations are present. For example, the school here, industrial sites, caravan parks, hotels, or resort locations. For this reason, CASA will generally use a qualitative assessment to determine the appropriate operational scenario. Now that we've assessed the area, we can now create the operational volume and ground risk buffer with the aim to achieve an iGRC which aligns with SAIL 2. Now you'll note we've excluded the school from the operational volume and ground risk buffer. By doing this, we've aligned the qualitative descriptors and the quantitative population values. So this achieves a desired outcome prior to exploring the need for mitigations. So taking the information gathered through the creation of the operational volume and the ground risk buffer, we've established an operation at a SAIL 2 without the need to apply mitigations. From this point, the applicant would need to achieve the operational safety objectives, or OSOs, for a Sale 2 operation. So that completes scenario 1. We'll now go into a little bit of a more densely populated area. So we're using the same RPA and air risk class. So just a reminder there on the left-hand side for following along. Right-hand side of the screen, you can obviously identify that the population is a little bit more densely populated. And the outcome we're aiming for here is a Sale 3 operation. So taking a closer look, the ABS data gathered for this operation indicates a maximum population density of not more than 430 people per square kilometre, which aligns to a quantitative assessment of less than 500 people per square kilometre. While looking closer at the density, population density to the west from a qualitative assessment, you can see this may not align. So as you can see with in the table that I'm about to present, the area description for 500 people are sparsely populated does not align with what is seen on the ground. Therefore, the determination for this environment would be consistent with a qualitative descriptor of suburban low-density metropolitan, or less than 5,000 people per square kilometre. The areas of single-family homes on small lots, small low-rise apartment complexes and low-rise commercial buildings. So we've now created our operational volume and ground risk buffer encompassing the entire area intended to operate within, okay, and that is depicted by the 3 circles here on the screen now. We've established through our iGRC that the operational area would be classified as an iGRC of 5 and not in line with a Sale 3 operation. So now we need to look at ways to mitigate the risk to the population in the operational environment. And for this scenario, we will apply sheltering. To achieve this, we refer to the M1 mitigation table located at R2 and R3 of the TMI. We've already applied a 1-to-1 buffer, the area between the yellow contingency volume and the red ground risk buffer. We have assessed the area and determined that the population at risk are most likely to be in homes or small businesses, and those buildings are of suitable construction to shelter an RPA of less than 25 kilos. The applicant has made the declaration that the population at risk will be sheltered and the population density at risk have been reduced by 1 order of magnitude. Supporting evidence for this is available to CASA, and as such, CASA has awarded a 1-point reduction by using M1 low. When looking at a sheltering argument, an assessment needs to be conducted of the environment to determine if sheltering is appropriate. This can be either due to the weight of the RPA or penetration characteristics of the structure. Additionally, where transient populations are present, sheltering may not be an appropriate mitigation. For example, the school in scenario 1, when outdoor lessons or recess may be taking place. So moving to the final ground risk class, with the application of sheltering, the final ground risk class can be confirmed at 4, which is identified there in green. The BVLOS in suburban low density metropolitan is the operational scenario using a 1-point reduction for M1 low. The applicant from here would be required to achieve the OSOs for a Sale 3 operation. So that completes the 2 scenario walkthroughs. I'll now hand back to Heath to discuss air risk. Thank you.
So in regards to air risk, the initial air risk class is determined using the corresponding airspace encounter category, which provides a baseline for understanding the likelihood of encountering other aircraft in a given airspace. Most operations in Australia occur above 500 feet AGL, with operators frequently seeking to reduce the air risk class from C to B. However, the current air risk model within SORA lacks granularity, which poses challenges for industry and CASA as a regulator. And CASA must assess these claims cautiously, particularly in areas with known traffic, to determine whether the safety case sufficiently justifies reducing the likelihood of an encounter to align with an air risk class of B. Should be noted, this added scrutiny may also extend the assessment timeframe. The SORA model considers the operator's ability to implement strategic mitigations, as outlined in Annex C, to lower encounter risks. These mitigations play a vital role in reducing the likelihood of an encounter with another aircraft and improving overall airspace safety. CASA uniquely allows the use of strategic mitigations developed through stakeholder engagement, provided they are supported by a robust safety case. The safety case must demonstrate that the encounter rate has been effectively reduced. So in other words, stakeholder engagement is not only about identifying who is in the operating area, but how you can effectively manage a lower encounter rate in order to reduce the air risk class. For example, an application may identify a communication plan to deconflict operations on a daily basis or restrict operating altitudes in certain locations. To further support risk reduction, practical operational restrictions can be applied. For instance, scheduling operations outside of peak activity periods, such as conducting flights at night, can significantly minimise encounters with VFR traffic, thus lowering the encounter rate. Ultimately, while strategic mitigations provide a pathway to lower the ARC, operators must present detailed and evidence-based safety cases that address the unique challenges of their operational environment and ensure that they align with the SORA requirements. The effort to reduce the ARC from C to B should not be underestimated, and that it is imperative for the safety of all air users that these claims are assessed appropriately. The tactical mitigations, you can consider these as controls in place during flight, and these are outlined in Annex D of SORA. These are required based upon the final air risk class, and we consider the current guidance as per the published documents on the JARS website. Shifting focus to standard scenario 7, CASA has introduced an additional airspace encounter category, supporting the SORA framework for certain parts of Australia. If you wish to take advantage of this scenario, you will need to view the documentation available on our website and design your operational area while incorporating all applicable airspace mitigations as defined in the document. This approach provides applicants with an opportunity to reduce the air risk class from C to B. JARS members, in regards to SORA 3.0, I should say, JARS members recently voted on the future vision of JARS. Although this was not a formal vote, there is a strong preference to focus resource on the update and release of SORA 3.0, which can be considered the update to the air risk model. And we're hoping to see more granularity in this part of the SORA as well. I should note, this does not take away from the current work program focusing on improving SORA 2.5 with clearer means of compliance and other guidance. We see this work as critical to our implementation and have many CASA staff contributing to this, with Rowan Kimber leading the Means of Compliance Task Force, which is a good segue into our next slide. And before I hand over to Rowan then Darren for the Q&A session, I'd like to take a moment to discuss CASA's short-term focus and next steps. So as part of our incremental steps towards the adoption of SORA 2.5, we will be considering the implementation of the updated containment methodology in due course. We understand that the current requirements can be somewhat confusing, ambiguous, and using the term again, lack granularity. We will provide updates on the progress of this periodically on our website and through the monthly newsletter, so please subscribe. Another recent focus has been a comprehensive review of our assessment process. We are committed to continuously improving our processes, aiming to identify more efficient methods and in turn streamline the assessment of applications. As part of this work, we have identified a streamlined assessment process for operators who have previously achieved a sale to operation. This streamlined process will generally be applied to subsequent applications of a similar nature. However, since there are many ways to achieve a Sale 2 operation, we need to ensure the streamlined assessment process is applied in line with the risk assessed in the initial assessment. Additionally, we've identified specific areas for Sale 2 applications where only a declaration from the applicant will be required. This declaration will be used as confirmation that they have achieved the necessary robustness for that particular operational safety objective, or OSOs. This approach relates well to our regulatory cycle and demonstrates where we can learn from our previous applications that we assess, gain a better understanding of the areas to focus on to ensure an acceptable level of safety is still maintained. And further information on this will be provided in the new year. I'll now hand over to Rowan, who will discuss the normalisation of operations from a policy and regulatory perspective. Over to you, Rowan.
Thanks, Heath. Thanks, Heath, and thanks, Warwick, for your presentation. Normalisation. So I'm fortunate to work with some exceptionally talented individuals and teams within CASA, and really importantly, some really pragmatic people. In the policy team in particular, but more broadly in CASA, we're big believers of regulating where we need to regulate and relaxing regulations where we don't. And so we've got a ongoing program of work about normalising of operations wherever we can. So that the concept of normalisation is that if we can identify operational profiles that can be conducted safely without the need of specific approvals, then we're moving to general approvals and changing rules wherever we can. So basically, in the words of industry, getting out of your way where we can do it and we don't need an approval, and we can do that in a safe way. And so this is a continually evolving project. We rely on data and insights from industry to identify those operations that we can conduct safely. We rely on tools like the JARIS SORA to help us assess that. But wherever we can, if there's an operational profile that we can identify that can be done without a specific approval, or it may well be that it can be done without some of the rigors of some of the other safety levers we've got. And in Australia, we've got plenty of them between the RePL system, IREX, BVLOS, OCTA, accreditation, ReOC. There's a bunch of things that we've got as safety mitigators. And where we can pick and choose the right mitigators for those, leverage models like SORA, then wherever possible, we're moving towards normalising those operations and making it so you don't have to do a specific approval. We'll keep doing that. And as with everything at CASA, we welcome any feedback there. If there's an operational profile that you think has got to the point of maturity now that it's time for CASA to start normalising it, to move away from a specific approval, obviously we'd love to hear that. There are some things we can't do, as Heath's already spoken about. We're in a tricky situation with some of what we do, particularly at airspace in Australia, in areas of the more ARC-C sort of environment. Even in some areas of ARC-B where we need to meet certain mitigation performance requirements in detection, we've still got some challenges we're working on. We have to keep Australians safe. We have to keep other airspace users safe. We have to keep property safe. We've got a lot of work that we've got to do there. And so we'll do what we can. Obviously, we can't do everything, but we certainly welcome anyone's feedback. So on that, I'm going to hand over now to Darren McGrath, Senior RPAS Inspector, to start the Q&A session.
Thanks, Rowan, and fellow panellists Heath and Warwick. So judging by the strong turnout on the webinar and the number of questions coming in, it's clear there's a lot of interest in the TMI for the alternate ground risk. So we've covered quite a bit of information so far, and hope it's starting to give you a clear picture of the purpose and advantages of this new TMI, what it aims to achieve, and how it can be applied to your BVLOS operations. So for those of you joining us late, my name is Darren McGrath. I'm a Senior RPAS Inspector at CASA. I'm pleased to be moderating today's Q&A session. So obviously the guys have been talking to you and downloading a lot of information. So now's the time to have a bit of Q&A. So to get us started, I've selected one of the common questions coming through, which relates to SORA 2.5 and the adoption of such. So question is relates to SORA 2.5 and when CASA will adopt it in full. So we have touched on this in the webinar, but I think it's probably a good opportunity to reiterate. I might pose this question to you first, Heath, if that's okay.
Yeah, thanks, Darren. Yeah, look, it's a really good question. You know, we are obviously very heavily involved in JARIS. and we try and be influential to ensure that our voice is heard and JARIS remains a fit for purpose model. In saying that, I think we looked at whether we could implement the full model and how long that would take to do so, and what the impacts would be on industry with that. We identified that there was some, low-hanging fruit that we could achieve quite quickly, and I guess the TMI is a proof of that. So a time frame for when we'll have a complete SORA 2.5 implementation is quite hard, noting we also have to consider 3.0 will be here in the next few years, hopefully. But I think what we're focused on, and hopefully what can assure industry, is that we are really actively looking at what the most beneficial items are within SORA 2.5 and implementing them as quickly as possible in that stepped approach. So I'll leave it there.
Thanks, Heath. Some good insights there, and just sort of highlighting the importance of planning when implementing any changes to the assessment process. And also, as Rowan mentioned earlier, CASA must consider how the model works in the context of the Australian environment. So thank you. So the next question, this is a common one we get as inspectors as well. So this question relates to the use of Annex F in determining an RPA's iGRC classification. So the question goes, if I believe my platform is judged to be in the wrong iGRC column due to its speed or dimension characteristics, however, I'm unsure how to apply Annex F in determining critical area calculations. So it's a very good question. I think Warwick touched on that earlier, so I might pass over to Warwick for answering that one. Thank you.
Yeah, thanks, Darren. It is a challenging question, but I think the key point to note from here is, as Heath mentioned earlier, that early engagement with CASA being the key part here. Coming to CASA with the idea of a platform that you're intending to use, we can determine if it is actually appropriate to use Annex F. And during that early engagement, we can identify how best to present the present the information to CASA if appropriate. It is important to note there that the application will generally be assessed by our airworthiness and engineering branch, and that will obviously taken into consideration, and that feedback will be provided to the applicant where appropriate.
Great, thank you, Warwick. So early engagement with CASA is the key takeaway there, I think. So the next question relates to applications submitted to CASA before the TMI for alternate ground risk was issued. So your application might be in the queue. So BVLOS application was submitted prior to the TMI. Do I need to resubmit and update the application? Heath, I might pass that one on to you if that's okay. So the question was related to applications prepared and submitted prior to the TMI.
Yeah, sorry, no, I was trying to find the mute button quickly. Applications submitted prior to the TMI will be assessed by the inspectors with regards to the TMI itself. As it does add that granularity within the model, it does present a more accurate model. So there's no need for applicants to update their safety case to represent the new TMI. They'll be applied unanimously, unless they wish for it not to be. But we would encourage just an awareness of the TMI. So if questions or queries do come back from the inspectors, that they are aware of what they're asking, what they're speaking to.
Yeah, that's a really good point. Thank you. All right, so next question. So I believe this question relates to determining population density at risk. So will CASA recognise certain land tenures that exclude permanent habitation, such as state forest or national park, when assessing a BVLOS application? So That's referring to population density. I think, Rowan, I might pass this one over to you.
Yeah, no problems. It's a really good question. So this comes back to the qualitative wording that we've got in the table. And if you have a close look at what we've got in that table compared to what SORA 2.5 has, you'll actually see some nuanced changes in the wording. That was intentional. There are things for the Australian environment that are different to other places, and we wanted to fit that in. I suspect it will fit into either an isolated or a scarcely populated environment, depending on the particular environment. And so it is something that gets assessed on a case by case. It wouldn't be, at least I wouldn't have thought that would go into being specifically a controlled ground area. So controlled ground area definition there, we've tightened that up over what SORA 2.5 has and what SORA 2.0 has, just to reflect what it actually means to be a controlled ground area and the way we can manage personnel. But we've added those really low areas, so the 0.5 people per square kilometre and the 5 people per square kilometre. So I suspect for a lot of those areas, they're already covered in the new definitions, and go and have a look at that. But just it does trigger one other thing to think about when you're in those sorts of environments. So a heavily wooded environment, and it would be assessed on a case-by-case basis, and it has to go to the inspectorate. But it's also worth thinking about what the application of sheltering is for those. So for an area that is heavily wooded, for the right platform, it might actually trigger sheltering. So things to think about when you're working through the application. I think the important thing is to understand what we're trying to achieve, what SORA is trying to achieve, and we're looking at number of people that are likely or potentially going to be impacted by an aircraft. And so you've got a bunch of mitigators to stop that. It could be between chronology, sheltering. There's a few things you can use for that, but just going right back to basics and understanding what we're trying to achieve.
Yeah, perfect. I think the qualitative descriptions are the key there. So I might stay with you, Rowan. Just keep your mic on there. I think the next question you might also be able to handle. So there has been quite a few questions around grid resolution. So obviously the UTMI talks to the optimal grid resolution, table A. And so the question states, a below 400 foot application, I would like to use 200 by 200 meters square grid sizes, but I cannot find a mapping solution that it can achieve this resolution. How do I go about representing this?
Okay, it's a really good question, and I just happened to have been in the room when this was discussed and made it into the SORA model, and it was quite a heated discussion. You can thank Australia mostly for the fact that it was such a heated discussion, and mostly because our data here doesn't support, for the most part, 200 by 200 optimal grid resolution. There are plenty of areas in the world that does, we don't. The reason the grid resolutions exist is to overcome a problem in SORA to do with smoothing. It's so that you can't go and have a grid size that's larger and then by average population density, lower your population density to allow you to operate over an area that actually has a higher population density in the corner of that area. And so it was dealt with to do with that. And it particularly helps for high level operations to be able to allow smoothing where smoothing should apply, when you've got a really large fall area. So the way to deal with grid resolutions in Australia is to do it in a qualitative way. And so the qualitative descriptors that are in the TMI and that are in SORA are actually designed around about that 200 by 200 square. And so we don't have the 1,000 by 1,000. Use the 1,000 by 1,000 as a good starting point, but then really go into those qualitative descriptors. You'll actually find for most operations, you get some benefit using a qualitative descriptor anyway, because in a quantitative descriptor, you're limited to squares, whereas in a qualitative descriptor, you're looking at different shapes. And so it's really easy to identify things like the outline of a suburb, the outline of a metropolitan area, and then you can do different sorts of buffering when you do that. So for the most part, the short answer is qualitative, but for the most part, you'll actually find a lot of benefit in your operation going that way.
Awesome. Thank you, Rowan. So the next question I've got here is a bit of an operational question, which I think is a good one just to vary the types of questions. So I'm going to put this one to Warwick because it's kind of scenario based. So the question sort of talked initially about VLOS as compared to BVLOS and how those two concepts of operation are assessed differently in the iGRC tables. So question goes like this: is it feasible as part of our ground risk mitigations to operate VLOS during takeoff and landing to depart from a sparsely populated area and then transition to BVLOS once in a lightly populated or isolated environment? So as the they're sort of applying two mitigations there. So yeah, might just hand this one over to you if you would like to, Warwick, or you can palm it off, up to you.
I might just quickly jump in there with the VLOS, just to consider that when we use the term VLOS with regards to SORA, there is an implied meaning of that, and that more or less reflects that you do have the ability to, under a VLOS scenario, actively avoid any persons that are on the ground. So just wanted to make sure that was clarified from a JARIS and SORA perspective. That term VLOS carries that definition in very simple terms.
Yeah, thanks Heath, and thanks for the question, Darren. So yeah, I believe it's a fairly easy one to answer. The VLOS is very much part of SORA, and the application in a holistic approach can and will still be assessed as a SORA-based assessment to ensure that the target level of safety is achieved throughout the entire operation.
Thank you, Warwick and Heath, for the insight there. That was really good. So yeah, VLOS as part of SORA and a mitigation is definitely part of the mitigation rather. So so the next question is to do with early engagement with CASA. So I guess the question relates to how an applicant should approach CASA, what is the process, and what information should they supply. So I guess this relates quite a bit to NXF. I might put you on the spot again here, Heath.
Yeah, sure, that's fine. So yeah, it was great. We've explained a lot about NXF, but not necessarily if you were to contact us, how you actually do that. And so I guess it's another thing that is an unknown at the moment, but the easiest way is our general rpas.pac@casa.gov.au email for that early engagement. I think just establishing that contact point and in the interest, and then we'll look to establish a more formal engagement moving forward. I'd still stress that you should be familiar with NXF before contacting us. It will assist in at least the discussions that would continue on from that. And it once again, because we haven't formally accepted it, we are still going through that review stage. So there may be some delays in that process, and you should expect, I guess, paving the pathway is sometimes a challenge in that respect.
Yeah, so I think, Heath, there we just want to sort of delineate between a BVLOS application going into a queue as compared to early engagement, and that, yeah, so that could take the form of.
Sorry, Darren, I should also mention we do have an advanced operations webpage, and it does have an inquiry form. It may present a easier method for you to log on or access our website and go through the online form. So it is a digital form, and it does provide some hints and tips. But in any case, just that early engagement, we just need to know who you are and start the ball rolling from there.
Awesome. I think we've ticked all those. There's a couple of emails around the same question, so I think you've probably answered all of those, and we can follow up where applicable. So another popular question I'm just sort of working through and summarising is relates to the qualitative descriptors. So CASA uses qualitative descriptors to validate the population density at risk. So the question, again, this may have been covered in the webinar, but it might be a good idea to reiterate here, given there's been a few questions around it. So question asks, why does CASA use qualitative description as the final validation? Now I'm happy to give Heath a bit of a rest here and lean on Rowan.
Yeah, thanks, Darren.
To take this one up. Thank you.
Yeah, no problems. So we spent a lot of time looking at this and talking more broadly with the JARIS community. Those nations who use the quantitative methodology do so because they have really good dynamic population data. And so, as Warwick mentioned earlier, we have big issues in Australia with the way census data is used in applications because it's captured at a very specific point of time, and it doesn't capture the movements of people. And so, for instance, you go to a school. I was looking at one yesterday. There was a school where there was 1,000 students at the school, yet the population data out of ABS said there were 3 people per square kilometre. And so qualitative allows us to fill those gaps in the fact that we just simply don't have reliable enough data in Australia to cover it. We've got a huge country. ABS has got data that was collected for a purpose, but is a different purpose to what we've got. And even the likes of Landscan, there's missing parts of the data. And by using qualitative assessments, it gives us a chance to make sure that we've got the assessment right. Because at the end of the day, the most important thing is that we don't underestimate the population density when we're trying to meet a target level of safety. Because the moment we underestimate the population density, we're not going to meet our target level of safety and the wheels come off. And so that's why we've gone for qualitative. It may well change if we get better data in the future as better data sets come on. But for the moment, we found that it's a much more reliable way of assessing the risk of the operation.
That's great. Thank you, Rowan. Well, time has definitely flown. We've got about 6 minutes to go. I've got one more question queued up here, and then we'll go into a little wrap up from each of our panelists. So question relates to how is CASA normalising and streamlining assessments and considering scale in the industry. So I think you might have touched on this a little bit, Heath. I might get you to take this one. Thanks.
Yeah, that's fine. I think this is where most of these inquiries come to me anyway. So as a team leader, I'm probably at the forefront and have a very good understanding of how long applications take and what the queue is and how to streamline. I think it's encouraging to see a focus within CASA on streamlining, finding efficiencies with all applications CASA-wide, but especially within the RPAS BVLOS space. And the TMI is a good example of where we've focused efforts for the benefit of all of industry. And unfortunately, we do have finite resources. And so the next phase of that was looking at the streamline assessment process. And so looking at how we can have an assurance that an operator meets a certain level and then conduct somewhat of a reduced assessment on subsequent applications. So I'm encouraged to see the rollout of this over the next couple of weeks and observe hopefully a reduction in not only wait times, but a reduction in assessment timeframe as well. I'll hand over to Rowan for the normalisation. I think that's more in your area there, Rowan.
Yeah, thanks, Heath. And it very much is a joint activity between the policy team and the oversight team at CASA. Heath and I were really fortunate to be at the most recent plenary in Vienna a few weeks ago, and we did a presentation to the plenary of JARIS about what we're doing in Australia for SORA and how our rollout's going. And we spoke about whether or not there's a future in the application of SORA on a specific case-by-case basis, and had a really good conversation with other regulators on realising that it is the more operators get competent, the more mature the industry gets, the more applications go in, the more resources we need, and that there is no future in that sort of a cycle. What we need to do is move to this normalisation that we're talking about. So those operations that as we learn and we grow and we know that they can be done safely, those operations move out of the approval cycle. And so our inspectors and our industry are working on the more complicated things, and that's what the model's for. And those that are safer, lower risk operations move to the normalisation general approval approvals. So we're going to keep doing that from a policy perspective to try and take some of the workload off the inspectorate so they can really spend their time doing the things that we really need the inspectorate doing on the complicated stuff. And the more simple, lower risk operations, we'll look to normalise those through general approvals and through rule changes wherever we can identify those.
That's great. Thanks, Rowan. So as I said, we're getting close to the end. So to finish up our Q&A session, I was just wondering if there were some last thoughts from the panelists, maybe just a couple of quick takeaways to end our session for the day. So I'll lead out with you, Warwick, if that's okay.
Yeah, thanks, Darren. My point, I think it's been touched on quite a number of times through the presentation. Basically, just reiterating the need to ensure that you're conducting your own qualitative assessment of the population density at risk prior to presenting that information to CASA. The sole reliance on ABS data alone can lead to a lot of unmitigated risks being identified through the assessment process, and that there can delay the assessment process quite significantly. So that's my key takeaway. Thanks.
Thanks, Warwick. Heath, how about you?
Yeah, just a quick one from me. I think I'm very positive and excited about the future for BVLOS, especially assessments within CASA, and I hope to see a reduction in wait times and also assessment timeframes.
Yeah, most definitely. And Rowan, this is somewhat your baby, so would you like to have the honour of closing out?
It's very much all of our baby, but thank you very much, and thanks for everyone for joining. I've got a couple of little points to go past, and I certainly won't take long, but I think one of the things that comes from a more granular table, and if wherever at JARIS and Australia stands up, people in the room say, what are you asking for? It's granularity, isn't it? I mean, yeah, that's what we want. That's our big thing that Heath and I have been pushing in the model, but one of the benefits of that is that done properly, it reduces the requirement to then use mitigators for ground risk. And so there was a comment earlier about how to speed up applications. Part of the way we do that is we reduce the need for inspectors to look at things. And so if you can carve out areas and use your granularity in the table right at the start and not have to apply for an M1 mitigator, then that's a whole component of the assessment that the inspectors don't have to look at, and it makes a huge difference in the processing time. So my key takeaway from all of this is the granularity really helps, but I guess more broadly than that is that this isn't about SORA 2.0 or SORA 2.5. It's about what works for CASA and creating a methodology that works for our local environment. It may well be that we never adopt SORA 2.5 in its entirety, because it may never be the perfect model for us. What we'll do though at CASA is to continue to work for a model that works for our industry and for the Australian people to make sure they're safe. And I think the TMI is a really good step towards that. So again, I want to thank everyone for joining today and everyone who was involved in the work that we're doing within JARIS and within SORA, within the TMI. And as I said earlier, the operators who have been continuing to push forward with these sort of operations and helping us all learn together. As I said right at the start of the presentation, we're all on a journey together. Learning is a together journey, and I really appreciate everyone for joining us today. So thank you.
Oh, thank you, Rowan. That was a great recap. Firstly, so can I say a big thank you to all our panelists for their time and insights today. Thank you to Senior Inspector Warwick Hickson, RPAS Team Leader Heath McDonald, and Emerging Technology Senior Standards Officer Rowan Kimber for sharing your expertise and addressing so many of the important questions raised during the session. So I'd also like to acknowledge there's still many questions we couldn't get to today. CASA will review the mailbox and identify common themes or deficiencies, ensuring we address these in future communications or updates. Finally, thank you to all of you in the audience for your participation and thoughtful engagement. We hope you found this session valuable and encourage you to stay connected as we continue working together on these important improvements for the BVLOS process. Thank you again and have a great day.